We have Rich Mogull this morning with Firemon. He is the SVP of Cloud Security. He is going to be giving a great speech, which is around the Cloudpocolypse. Is that a technical term, or is that your term?
Like Shakespeare, I make up my own words.
Okay, we're making up words this morning. That's good. We love to do that in cyber. Amongst other things, he's faculty at IONS, which is fantastic for many years, and just overall a cloud security expert. He's literally written the manual, if you will, on cloud security, so we're going to learn something today. Lots of experience. And please, let's make it interactive, especially at the end. If you have questions, raise your hand, throw something. Let's get his attention. But I would definitely use it. When you hear things throughout the conference here today, ask questions at the end. Great chance to meet a technical expert and learn something new. So please welcome Rich. Good morning.
Thank you, everyone. All right, so 2 safety points in this room. One is there's an X there, and I see lights there. I'm not going to stand on that X. I know how this ends. I've watched television. The other, this is a pretty big stage, so I will do this so you know where I am as I'm walking around giving my talk here, in case something happens. All right, so welcome to Taming the Cloudpocolypse. And this is a presentation based on some hard-won lessons over the years. So in my background, the work I do with Cloud Security Alliance and with IONS and my own org, Securosis and Firemon, I've worked with a lot of organizations where I've had to go in and help them fix cloud issues. A bunch of this content I also co-authored with a guy named Chris Ferris, and together we have both dealt with this. He's dealt with Warner Media, and he's over at FanDuel these days. We've done a lot of work in a lot of different big organizations. So let me set the stage for you. You are the new director of cloud security. It's a really cool title. I mean, like, I like titles like that. But now that you're here, we have a few things we need to share with you now that you've been hired. So the developers started experimenting with cloud a while ago. It turns out they accidentally built some production apps or moved them there without talking to anybody. And then management's like, oh, that's really cool. So we're going to like move everything out of the data center up into the cloud. And well, the developers, like, they need Google. And like, I know we start on AWS, but Microsoft's given us like a good deal. We've got a bunch of credits we need to use over there. And then Oracle's being turd balls and making us use them. Otherwise, they're going to remove our support discounts because that's what Oracle does. Larry needs another island. And we can't let security introduce friction because it's going to slow the developers down, and everybody gets to do what they want. And then we have like thousands of findings because somebody got budget for a CSPM, and like, oh crap, what do we do now? So good, you're hired. We're only going to pay you about half of your market value, but we need you to get this fixed because the auditors have discovered that we actually are in the cloud. And then we apparently have been crypto mining for a while, and we just had a ransomware attack. And oh, we bought somebody who's all on Azure. We don't know how any of that works, and we cut all their Azure people because we need to save budget on headcount because we saw Cisco fire like all their good people, so we got to copy them because they're so successful. And there's like a security program, but we don't have a cloud security program. Is anybody having an emotional reaction? Have I triggered anyone in the audience right now? Yeah, hands going up like, oh God. This is what happens. This is what we often are dealing with when we walk in the door. And even if you're already in an organization, a lot of you know. And look, it's not that people are being stupid. This isn't a blame game situation. I don't blame the developers. I don't always blame the business. This is an incredible technological transformation that we are all undergoing at this point in time. And it's moving very, very quickly. And even as fast as it's moving, the last stats I showed were something like only 16% or something like that of enterprise workloads have actually moved into cloud. We've got a big runway in front of us as more and more is moving up there. Are we going to get rid of data centers? No. But are things changing? I think we all know they are. I got involved in cloud 15 years ago. Or well, almost 14 years ago. 2010 was my first AWS account, and when I started doing work with the Cloud Security Alliance. And you know, these are real life situations. As much as I was exaggerating and using some AI art, this is what you get when you say, "Okay, give me that, but now with zombies." So kind of cool. Give ChatGPT a little credit for that one, or DALL-E. So the reality is most organizations are moving to cloud rapidly. There's a lot of benefits to it. There's also a lot of confusion. I had a call last week with somebody where I was giving them advice on cloud stuff, and I'm like, you don't have to move everything to cloud. Like if it's paid off and running in your data center and works, you don't just migrate it up there. You get none of the benefits of cloud if you just throw crap up into the cloud. If you want the agility, the resiliency, the economic, and the security benefits, all of which are real, you need to go up in a methodical way. But that's not what the cloud providers tell you. That's not what most of the consulting companies tell you. And your developers want to play with the new tools. So there's a lot of pressures to move us up there. So what does this mean? It often starts with experimentation, then there's a flood. Migrations start before effective governance and controls are established, and security is often sidelined because of the movements here. And because security, unless you live in this world like I have, you don't have the knowledge yet. Skills and staffing are a legitimate issue in cloud. And let's be realistic here. And then, by the way, they're going to say, well, we're going to go multi-cloud. We'll just put everything in containers and run it everywhere. Which, by the way, you know that does not work. Okay? You can maybe make it work, but odds are you're going to have more failure there than you're going to have success, and you're going to pay more money. And we can get in all the reasons why. You can ask me about that stuff afterwards. So let's put this into perspective as you're dealing with all of these issues. I started on AWS in 2010. I started in Azure, I can't remember, probably about, within 5 years after that. On AWS, I think I'm pretty solid. I'm a community builder. I'm considered an Amazon expert. I work with the APIs. I also work with executives. And I barely can hang on to what I need to know from a security standpoint on AWS. I don't know all the settings and all the capabilities and all of the AWS features. And my job is a full-time researcher. And I have built security platforms and companies on AWS. Now, Azure, I know enough to hang on by my fingernails. And GCP, I can't even spell properly. So that's the level of knowledge gaps and challenges that we're dealing with. And at the same time, cloud security changes and challenges our traditional operations. A lot of what we have built in terms of security, and very rightfully so, this is not a criticism, but very rightfully so, a lot of what we have built in security is because of the scarcity of resources in a data center. What do I mean by that? I have a data center, and I only have so many places I can put boxes, and I only have so many floorboards I can rip up and run wires. Somebody who wants to build a new application has to request permission to get the limited resources of a data center. And much of our security was designed around those processes in our IT operations. We can control because we have to control. Somebody can't just go throw their own server into the data center. I mean, they sometimes have. I mean, those things have happened, but you know what I mean there. That's not a problem with cloud. Because with cloud, anybody with a credit card can get a Class B network in under 5 minutes and deploy thousands of resources on it. Okay, you got to do a service limit request to get thousands, but it's not hard to do that. And they can have as many of those as you want. So we have lost that scarcity, and we have decentralized operations because teams are now able to build their full infrastructure stacks without having to go to networking unless they need to connect to an existing network. They don't have to go to somebody to provision a server or a virtual machine. They write their Terraform code, and it's just done for them, or they click through the console. It's an entirely different operating model than we have dealt with, and not in a bad way. I think it's a very good way, but it is different, and it means our security controls of focusing on managing those perimeters, managing that scarcity, go away. Then at the same time, as decentralized as all of this is, the administrative functions, the management plane for all of this is at portal.azure.com, console.amazon.aws.amazon, or Amazon, I can't remember because I type it in so much it just auto-completes. Yeah, I'll Google it. So it's the entire management plane, all of our administrative functions, down to literally unplugging wires and plugging in and creating and destroying entire networks, is at a single user console and a single set of APIs that are all public on the internet. Okay. Well, we can protect this, right? Yeah. We give people usernames and passwords. Maybe MFA. It's not required. It's only required in some cases. I'll give Microsoft credit. They're horrific at security right now, but that is one area where they've improved dramatically requiring those kinds of things. So everything is identity-centric, and everything is on the internet, and anything you deploy there on public cloud, guess what? It's public cloud for a reason. We didn't make up that word. Anything is potentially public on the internet. These are very legitimate challenges as we're going through this massive transformation globally. So with that stage set, I'm going to blast through the rest of this, and I take a perspective from disaster response. Does anybody recognize that location? That's the Reliance Center. I don't know if it's still called that. So I was deployed here for Hurricane Katrina. I'm a federal disaster responder, paramedic. And one of the things that I've realized as I've been doing a lot of this work in IT and IT security over the years is that we can take a lot of the skills and processes that I've learned as a disaster responder, and we can apply those to our IT problems. Now, what is the definition of a disaster? Technically, I'm fudging. It's the definition of a mass casualty incident. And a mass casualty incident on the medical side is any incident that exceeds available resources. So if I show up on a car wreck and there's 3 cars with 2 people in each car and they're injured, that's a mass casualty incident. Doesn't need to be hundreds or thousands of people, because I can only take and transport 1, maybe 2 patients if I'm really good and they're not really bad. And so from a disaster response scenario, you can think of walking into an environment like I just described, the Cloudpocolypse, as a disaster response. And we can use those skills and terms. But we have to translate that for what we do. I'm not one of those people that's going to start throwing out words like OODA loop and all that military jargon, because in a non-military operational domain. What we want to do is take the lessons of disaster response and apply them to the realm of IT security, of cybersecurity. And so here's an example of how I have mentally changed my constructs around this. So on the left side is something known as the Advanced Medical Life Support Algorithm. AMLS is a certification that I renew every 3 years as a paramedic. You don't have to have it, it's just a nice one to have. It's for dealing with advanced medical kinds of problems. Well, the idea is, and what we do very well, extremely well, in emergency services and disaster response, is we have built processes to handle anything. It doesn't matter what's in front of me. If I follow the algorithms, that will keep me focused and that will keep me on track. And I might still suck at my job, doesn't mean I'm going to be good. Something might go outside the boundaries of what I have the knowledge and skills for, but if you stick to the algorithms, you're generally not going to get yourself in trouble because you're not going to miss things. It's the same thing in aviation for my pilot friend in the audience. So if you stick to those checklists, if you stick to those flows, if you stick to that process, and we can use those in IT security. So let's walk through the process that I've come up with for dealing with these kinds of situations for cloud, or me and Chris Ferris, because we work together on this. The first is we have to orient ourselves. And this is true when I show up on a scene, we call it scene size up, and my initial assessment. In our orientation for these cloud situations, the first thing we need to do is this flow right here. 1, I need to find my accounts. Accounts is an Amazon account, an Azure subscription, a Google project. That can be harder than you think. In many cases, you have to go to accounting and finance to pull that information and pull that list together. I may have a slide on this. It's a newer deck. I can't remember exactly which slides I have. Next is who owns those environments. And this can take a lot of time. I have gone in to do security assessments of large organizations, and I find an account, and then I look at the root account, and it's a contractor's email address and personal cell phone. Like, that's not unusual because somebody just did something and never properly handed those things off, or the employee doesn't work there anymore. So you need to find the business owners, you need to find the technical owners. Then, do you have cloud security posture management? I'll talk about open source and commercial. There's open source options here. If not, you need this. I'm about to start a project with somebody who doesn't have that. And I'm like, it's astounding to me with how much they haven't already used this. I hate to tell people to buy things. I hate to tell you to spend more money on security tools. Because even though one of my jobs is as a vendor, let's be honest, half the time it's a grift in the security industry. But you need the right tools to get your job done. The cloud providers are not giving you the tools you need. Or if they are, they're charging you as much as the third-party vendors, so you're gonna have to go that route. And then you need to identify your telemetry. Why? Cloud security posture management gives me visibility into how things are configured. My telemetry, my security telemetry, gives me visibility into what's going on. And those are the two things I need to know. So finding accounts and owners, and it's just a bias because I do more in AWS. Deployment is the word we use at the Cloud Security Alliance these days for this. Super critical. It's who can make the decisions from a technical standpoint and from a business standpoint around those environments. And you need to pull these. And sometimes you're going to have to go to finance to do this. That's one of my tricks. You go to finance and you see who is paying the invoices for cloud, and you see who has cloud providers. Like Amazon, AWS, and Azure show up differently on your credit cards than like if you're buying toilet paper on Amazon. By the way, I was a leader in buying toilet paper on Amazon. Like when the pandemic hit, we were totally covered with our toilet paper. The rest of you were just catching up. So accounts and owners finding out, because at some point business decisions will need to be made. You know what you're gonna find too is this is where you can be a freaking hero in your organization. You are going to identify a large number of environments that are wasting a lot of money, and nobody has like ownership and knows what's going on with those. So in your research around here and pulling this together, if your organization doesn't have it, you're gonna be providing a ton of benefit to your organization in terms of some cost reduction. Then let's get some telemetry. Let's get the logs. We love logs. Like we're the security folks. We love our logs. There's fewer things that we like to hug more than logs. Like if I have logs here and my kids over here, it's a little bit of a toss-up depending on what they're doing that given day. So the main one we need that's critical for what we're focusing on in taming this chaos is your management plane logs, your cloud audit logs. This is going to tell me, why does this matter? Go back to what I said about the differences in cloud. And one of those big differences is the whole management plane is unified, and it's on the internet, and identities are the big thing. It's bad if somebody hacks into a virtual machine in my environment, an instance. It's worse if they hack into my management plane, and now they can control multiple data centers. And that's equivalently what we're talking about here. And all the cloud native attacks are identity-related attacks, and all of them are detectable by getting into the cloud management plane. I worry about the management plane long before I worry about what's on any individual instance or container that's running in my environment. So that's got to be your top priority. You also want to turn on the threat services from your cloud provider. They're not free, unfortunately, but like GuardDuty and some of Defender for Cloud, Google Security Command Center, because those things can usually detect live attacks at less cost and complexity than you doing it yourself. Can I detect a brute force SSH in AWS by turning on the DNS logs and the flow logs and the load balancer logs and also all the other stuff? Yes. Or I just turn on GuardDuty and it's going to detect that for me because Amazon will actually seize all of that activity. Here's something to understand about logs in cloud. Cloud provider always has this data. It's just a matter of you pay money when you save it someplace so you can retrieve it later. That's where the cost comes in. It's not that they don't turn on flow logging. It's always there. It's just you're not paying yet to store it and access it. When you turn on some of these things like GuardDuty and Defender, they're doing all the analysis on that, but you're not paying those storage costs. So it can be more cost effective than turning on all of those things. And if you have identity logs, your SSO portals get that stuff as well. It used to be actually really hard in Azure to correlate somebody's sign in to the API call. The API calls wouldn't tell you, and you had to like do all sorts of effery. I'm being good with my language today, but you know what I meant. Like, who here has seen Deadpool? I can use whatever words I want now. So, oh God, that's such a fun movie. Okay, so I'm getting my logs and stuff. I've got CloudTrail turned on. I've got the Azure logs turned on. By the way, you typically will get 90 days of those accessible via API. You want to start saving those down and start considering your analysis. Then, cloud security posture management. And early in this, it is your hasty CSPM. So in like rescue, we used to go, I did mountain rescue for a while. I'd be on a hasty team. The hasty team is you go light and you go fast. My job is to find the patient and stabilize them and then flood all of the other resources in. That's what a hasty team is. And that's what we're talking about here. So if you don't have tooling in-house, you can start by going to get open source. There's a few open source CSPM tools out there. Some of them from like Prowler is a commercial, but they have a wonderfully well-supported open source version. I think Scout Suite might still be around, and there's other open source tooling that you can use if you don't have your own thing. And so this is, my goal is just to find the really, really, really bad stuff. What does that mean? I ignore anything below critical and high. And then the critical and highs, I ignore anything that doesn't have access into a production environment. And that's how I'm going to get my initial focus. This is triage. It is triage. You're going to be focusing on the cloud resources with misconfigurations and things that shouldn't exist and things that are problematic. Is it public? Is it under active attack? There's all sorts of things. You don't need all the fancy attack path methodologies. Those things are fun later. Right now, you're just looking for the really big, gaping security holes that are of immediate concern. And I'm going to detail those later. We've got it in here. And so now I've got my worst of my worst, and I'm going through my triage process. As a paramedic nationally, we all mostly use something called START, Simple Triage and Rapid Treatment, Rapid Transport. And this is a way, it's an algorithm, I didn't put it on the slides here, for figuring things out very quickly. What does that mean? If something really bad happened in the room to all the people here, okay, if you have a heart attack, you get all of my attention. If everybody gets a heart attack, I walk around the room, open your airway, are you breathing? Nope, you're dead. I'm moving on to the next one. I don't spend any other time, okay? Are you bleeding? Can I throw a tourniquet on really quick? Yeah. Can I not? Okay, sorry, you're also dead. And I don't mean to make light of it. It's like our tough situations, but that's what this is. You're focusing on the things you can fix and the things you can fix quickly at this point. So it's information gathering. You're going to use this to feed into the cycle. But what you're looking for is there a stop the bleed moment. Oh, all our customer data is in a public Azure blob. Well, I'm probably going to fix that immediately and raise every alarm bell, even though I'm still just in an information orientation gathering stage. And again, free and open source can help with a lot of that. So we've done our orientation, we've started our prioritization. How do you prioritize? Chris and I, when we put this, the origins of this content together, we've used it in a few different ways. We wrote something called the Universal Cloud Threat Model. And that's available up at the link somewhere. I know I've got it somewhere on here. Yeah, sorry. So it's on this slide, the Universal Cloud Threat Model. And the idea of this is that if you think about it, we are all in the same platforms in public cloud. We are all facing the same universal threats. You've heard the saying, anything you put on the internet will be attacked and scanned basically immediately. We know that. There's a lot of research on that. We know the kinds of attacks. That's very well known and very well understood. This is the evolution of that into cloud. And a large part of the focus is exposed credentials, which I'm going to get into. So the reason we wrote the UCTM is we realized that there's a lot of great cloud security research out there, a lot of it from vendor research teams. Well, I'm not knocking them. I've got friends on those teams. But their job's to find like the really hard stuff and to get into the press. Doesn't help most of you who are still at the 101 level of what you are dealing with cloud. Because you're not worried about the latest new hypervisor attack that affects only version 3.7 of Amazon Nitro, which, by the way, I don't think that's not a true statement. There are no vulnerabilities there. Don't get angry at me, Amazon. You know where I live, because that's where the toilet paper goes. But the idea is we wanted to address the main gaps in these non-cloud threat models. So MITRE ATT&CK is great. They even have a cloud focus. Their Lockheed Martin cyber kill chain stuff, there's a lot of those. But they really have not done a good job of helping you prioritize. So the UCTM is not meant to be the be-all, end-all of threat modeling. It's a very simplified model. And it's focusing on 90% of what 90% of you need to deal with. That's, by the way, it's not 87.38% that we rounded up. It's some fake thing I came up with because I used to work at Gartner and we just make up numbers. That was like 17 years ago. I've improved my math skills since then, mostly to keep up with my kids in middle school and high school. But 90% of what 90% of you need to deal with. And I do have some backing for this. So for example, I was talking to a friend of mine on the AWS customer incident response team. And I think their stat, and this is not a hidden stat, is around 66% of their customer incidents originate with an exposed credential. Why the hell are we worrying about these complicated, like, token manipulation attacks and everything else if most 66% is somebody just posted the credentials on GitHub, which is pretty much what it is. And so in the model, it's a Mad Libs. Threat actors have objectives against targets using attack vectors that you see as a sequence of attack. And what we know is from the big gaping security holes, there are two things that lead to me coming up with that roughly 90% number. And by the way, it's not a BS number, because if you look at like the Mandiant reports, and you look at the CrowdStrike reports, and you look at everybody's and the Verizon reports, if you distill down what they're saying about the cloud attacks and those threat reports, it kind of comes really close to our qualitative assessment here. And the main one is these exposed credentials, like access keys. And this leads to, it aligns with the sequences. A key thing about the UCTM is that there are undifferentiated attacks and differentiated attacks. What do I mean by that? There are a lot of attacker toolkits today that when they get an Azure token or Amazon access key, it will go into an automation platform that executes a series of automated attacks. And those attacks are largely going to look at crypto mining, and they're trying to compromise SES, simple email service, to do spam and phishing kinds of things, and maybe ransomware. That's a really big percentage of what those automated tools are doing. We know this. And if you can knock down that vector and those sequences, now you can start worrying about the other stuff. The other side of it is when you expose something publicly. You have an instance exposed to the internet. So I run this thing, it's a free newsletter, Cloud Security Lab a week. Tell your friends, like and subscribe. And the lab I just did was like 2 weeks ago. I actually have everybody deliberately open up SSH to a running instance in their environment, and then we have everything wired that they'll get guard duty alerts over email. And within 3 to 8 hours, everybody gets an email of SSH brute force attacks. So anything that's exposed publicly, we know, is the other big source of these attacks. Or you just make your S3 buckets public and you do the work of the bad guys for you. And so those two vectors alone, if you, wow, my cat got on my keyboard. C, that's, I don't know where that came from. And so here's an example of what a sequence would look like. These are in the report. I'm just going to click through it. But for example, with ransomware, there's different ways it can start. They can hack into an unpatched system. They can pivot into the management plane if there's credentials there. It's similar to what happened in the Capital One attack. Or they can just directly get access keys that they were posted somewhere. Then they can do that. Turns out they don't encrypt the data in cloud. They just copy it out, and then they either delete it and ask for money to get it back, which maybe you get it back, or they just copy it out and they say, we're going to blackmail you. But that's an example of what these sequences are. They're very well known, they're very well trod, and they're highly automated. So what do we want to do now? We understand what we have, who owns it. We know, or we've prioritized to the big gaping security holes using a threat model. And when you really use a threat model, you do customize it to your own needs and your own organizations. Then we get into containment. And for containment, this goes back, this is a modified version of that START algorithm that we use for real-world human blood and guts triage. Is what I've got exploitable? No. Great. I'm not going to worry about it. Is it in the UCTM? Well, if it's not one of those 90%, I can delay my response to it. Is it in the UCTM and it's fixable? We immediately fix it. And if I can't fix it easy, then it's called expected. Expected is like the dead and the almost dead. Then you have to have very hard business discussions and likely have to talk to your insurer. What's an example of an expectant? If you already have a public S3 bucket and you know somebody has the data, or you're in a ransomware attack and now you're in negotiations for how much to pay, you're black. You're not red. Like, you're in an emergency recovery kind of situation. And these are examples of some of these big gaping security holes. 3389 open to the world, missing multi-factor authentication, access keys. That's the stuff that you feed into this algorithm to make those decisions. So we've gone through our initial steps. And this is an example. That photo I showed you of the Reliance Center, when I first came to Houston, we were in our rental trucks. Our gear was being driven down from Colorado. I live in Arizona now, but I'm on a Colorado response team. We were driving to New Orleans itself when we got we just happened to hit, somebody got a text message that said, turn around, because it turned out all the buses were going out of New Orleans to Houston. Any of you who are living here probably remember when all the evacuees came flooding in. So we head back over, and we set up, and we triaged 900 patients in 3 hours. And then we set up our little base area, and we ran that for about 2 or 3 days. By day 3, we weren't getting any buses anymore. This is where you are starting your transition. The disaster's not over, but there's a transition state from your initial response, and then now that hasty team, all these other resources start coming in, and I have all of this, more things available, and I have more knowledge of what's going on. We have to move into operationalizing what we're doing. And this is where you're moving now from that emergency, let's get those big gaping security holes, into now we need to establish a process. But it's not like you instantly go from emergency to emergency over day to day. There is a transition period around this. What I've got on the screen here is something known as the planning P. If you ever take ICS 300, Incident Command System 300, which is the baseline level to be a member of Command and General Staff on like federal incidents, you learn about things like the planning P, which is where what you've done is you've initially identified all your telemetry, you've got most of those big gaping security holes closed, or you're addressing those, you prioritized your focus using the Universal Cloud Threat Model, and now you're starting to deal with your politics. Because now you're going to have to start reaching out to the business units, working with the owners, working internally, looking at structural changes to your organization. This is where you start the planning cycle. In the planning cycle, you define operational periods. That's what we call it in disaster response. What do we call it in IT? Sprints. So I'm going to set up my 1 week or my 2 week sprints. I'm going to follow a process for having clear defined goals during those operational periods and start transitioning into more of a daily operation mode. This is where I have to start looking at my tooling and staffing issues to meet the demands of whatever I have learned during that initial response. Do I need a permanent CSPM or CNAP tool? Do I have an effective inventory of my cloud resources? Do I have good API logging, or do I need to upgrade my logging tool? Because it turns out that ArcSight is not very good at dealing with cloud. Sorry, anybody still on ArcSight here? I almost always run into somebody, no? Or are you just too ashamed to raise your hand? So, okay. Somebody's shrugging like, what's ArcSight? And I'm like, now I know you're young. It's like when I was at a table with a bunch of people and they're talking about like platforms. I'm like, oh yeah, McAfee ePolicy Orchestrator. And they're like, what, my home antivirus had what? And they don't remember when McAfee and Symantec were actual companies. All right, identity federation, secret scanning, and starting on your security bill of materials. That means you're going to be doing your software composition analysis and code scanning stuff. These are the things that I start layering in, and each of these could be a talk on their own. Now, in some cases, you're going to build it. In some cases, you're going to buy it. And in some cases, you're going to download your open source. And these can be difficult decisions. This is kind of a flow chart that I threw together of an idea of like, hey, if I have like very little budget, very little time and experience, and a small scope, maybe I can build something my own. But, or I'm just going to have to buy. And there's no right answers to all of this. There's usually going to be a combination of build and buy in most of your organizations. And if you're one of the Bay Area unicorns, you can build all your own stuff. I see that. I have a lot of friends who do that. Most of the rest of you are probably going to have to start with products. You be careful. Don't let the vendors define your security program for you. Your objective here in these planning cycles and the prioritization is so that when you pull these things in, you define your own priorities. And you are able to figure out what makes sense for you. And absolutely don't let the cloud providers make these decisions for you, because their solution architects is probably one you're going to have to rely on a lot when you bring them into the door. But they're the ones that are going to drive you towards just using more Microsoft, more Amazon, more Google. So you're starting to layer in long-term tooling, long-term technology, and long-term business processes. And again, it will take a while. And so thinking in terms of sprints with defined goals to kind of guide you along as you're trying to mature all this makes a lot of sense. And your idea is to go from reactive, running around and fixing everybody's problems and blocking and tackling, to engaging with teams earlier so that they are creating fewer problems. They understand why you are focusing on the things that you're focusing on, and you can start putting some guardrails in place. You're going to start with detective guardrails, a lot of alerting things, and then you can do preventative guardrails. All the cloud providers support things like service control policies and Azure policies and permissions boundaries, security invariants, automation tooling. These are all things you can start sliding into place to knock down. So with Amazon, they've got a feature called BPA, public access. You turn on BPA, nobody can make public S3 buckets. There will need to be exemptions. So you have to plan your exemption process out, because sometimes you do need public buckets. Like my platform, our website is, we don't have a web server. It's an S3 bucket that's set to function in web server mode. It's a fully serverless, single-page application. You're going to encounter those things. So always make sure you have your exemption pathways around all of that. This is where a lot of it becomes politics. This is where you want to go to business school if you haven't, or read the book How to Make Friends and Influence People, or learn the fine art of bribery at this point. Because now there's going to be a lot of conflicting needs and requirements. This is where governance really kicks in. And if you have bad executive leadership who won't draw lines, and they want you guys to all work it out amongst yourself, like I have 3 children. If I tell them to work it out amongst themselves, I get to use my triage skills. It doesn't always work out really well. So you need to have good leadership and guidance and coordination around this stuff. And this can take 1 to 2 years, just being realistic. Your initial response stuff is typically months. Your really, really bad stuff, I mean, typically still going to be months to get through a lot of that. Maybe at the end of a year, you're in decent shape in getting together what you want to have done, and you can submit for your budget cycles for next year. And that's just real world, unfortunately. It can take time to do this. But a 1 year, like a 12 to 24 months, I can usually see programs completely transformed when they start going down this path. Because we're moving from pandemic to endemic at this point. And we're now focusing on operationalization and automation. Like, what are my systemic security issues? Something called just cause analysis, which is instead of fixing blame, what's the core problem that we have? Why are things being made public? Why are access keys being exposed? Almost always, it's a combination. It's not training. It's not negligence. There's some of that. If someone's negligent, they're negligent. You discipline them. But lots of times, it's you're not setting them up for success. You're not giving them the tools. You're not giving them the capabilities they need to be successful. So they're going down the easy path. You need to make the right path the easy path. Lots of IAM users or public buckets. There's tooling, and these are common systemic issues that tie back to the threat model. I hope all this looks, by the end of this talk, kind of wraps up in a bow and should all be aligned. Then we have things that you can use to help manage and build your program out. So this is the Cloud Security Maturity Model. I wrote it, but we released it through IANS and the Cloud Security Alliance. And it's designed to give you the story of what a mature cloud security program will look like. And there's a spreadsheet that accompanies this, and that spreadsheet has key performance indicators for every maturity level in every single category. Is it the be-all, end-all? No, it's not meant to be. The problem is you will be overwhelmed. If you take NIST 853 or even the Cloud Security Alliance CCM, and you just try and start with that, it's overwhelming. The idea of this is to give you KPIs aligned with those other models so that you can actually help measure and prioritize the things that you're doing in the long term for your program. And it fits in with this thing I call the governance hierarchy. This is stolen right out of Cloud Security Alliance training, where you have that high-level framework, and the maturity model can function as that, or NIST CSF, or both, because the framework, my model is designed to work with NIST CSF. A high-level framework that is, where are the buckets of my security program? That's what that is defining for me. Then I have my control objectives, which is, what are the outcomes I need to have? An outcome of a control objective is all human access to cloud will be through our SSO portal with multi-factor authentication enabled. That's a control objective. And then the control specification is how do I do this in Amazon? How do I do this in Azure? How do I do this in Google? And you get this nice framework lined up of this individual control specification this part of the framework. And that's how you make sure that you've got your bases covered. It's an interlocking series of tools to help us make sure that we have the proper governance. And it aligns with the threat modeling, and it aligns with the results I'm getting out of my tooling, ideally. All right, how do we put all of this together? Start by looking at the threat model to help you prioritize what your biggest exposures are going to be. And maybe you just start with the two things I just said earlier, the exposed credentials and the public stuff. But there are capabilities, in the way the model was designed is that you can tune it, because those of you in financial services are different than those of you in utilities, are different than those of you in government. There's going to be differences, or education, in those areas. Then, start identifying your big gaping security holes and use the algorithm here. Is it a minor, delayed, immediate, expectant? This is just triaging our issues. All of our tools, low, medium, critical, high. But the thing to remember is your security tooling will give you a critical or high based on like its definition of how bad it is, but maybe that isn't bad for you in those circumstances. This is why you have to have your context. You can't just let your tools drive your processes. You want to have your processes and your governance drive your tools around this. Because just because it's public doesn't mean it's bad. It depends on what's in there. So you always have that, what is the actual problem, misconfiguration, and then what is the context around that. Then, start to implement guardrails to reduce these. Block public access, implementing service control policies, implementing Azure policies, Google policies, to really start knocking down the problems so you're not creating new problems as you're trying to follow the train and fix up all the various old problems. I threw a lot at you. And we've got a few minutes left, 4.5 minutes here for Q&A around this. But the one point I want to emphasize is that realistically, many of you will get dropped into situations like this in your careers where it's just absolute bedlam chaos. And all it is you got to keep yourself centered, follow the algorithms. They're there to help you. We do have tools to focus on this. And if you focus on the worst problems at the beginning, just give me my scope of my orient, prioritize, fix the bad stuff, contain, and then operationalize. You'll be in good shape. All right, with that, do we have any questions? I know it's intimidating in the big room with like 4 people. All right, thanks everybody for your time. I'll hang out for a sec if you want to come up and ask anything.